all video, so there's no questions. They're early alphabet. I got you. Okay. All right, what have you guys written so far? Say again? HCl. Okay, hydrochloric acid, HCl. And do you guys think that's aqueous? Most acids are liquids, right? But we don't call them L, we call them aqueous. Plus what? K2CO3, those are carbonate. And that's going to be a what kind of reaction? Double replacement. So we make KCl and carbonic acid, H2CO3. All right, so let's classify these as we go. This is a aqueous, but it's what kind of acid? Strong acid. So as you're starting, I'm going to just put some notations here to give you the idea of how you know how to proceed. So your strong acid, this is carbonate, right? Well, our carbonates in this case are going to be soluble. And it's a group 1 metal, right? Anytime you see group 1 metal, you're saying aqueous. So this is a soluble salt. SS, soluble salt. Oh, I haven't balanced it yet. Don't make me forget to do that. This is a fluoride with a group 1 metal, so it's going to be aqueous and a soluble salt, okay? And then this is an acid technically, right? But it's a weak acid, so we don't ionize it. We don't touch it. But what did I tell you about those couple of products that are kind of unstable? What do? They break down further. What does carbonic acid break down to? H2O and CO2. So I'm going to put like a little arrow and put secondary, with a 2 with a little 0, to tell me I have to break through a secondary breakdown with that specifically. Okay, before I go further, let's balance. What's missing here? 2 in front of KCl and 2 in front of HCl. We good here? All right, so as we go, can I break this down? Yes, all right, it's going to ionize into 2 H pluses and what? 2 Cl minuses. Don't forget your ions, okay? And then this is a soluble salt, like you guys said, so it's going to be wet and wet. 2 K pluses and a CO3 2 minus. That's our carbonate ion, yielding. What's next? 2 K pluses and, say again? 2 Cl minuses, okay. Making sure you put your charges. And then what do I do with this? Break it down to what? H2O and CO2. Okay. So this is kind of our total ionic equation where we are now considering where our spectators fall. Who are the spectators? Potassium ion and chloride ion. Everybody else stays, right? So what's our final NIE here? 2 H pluses plus CO3 2 minus. I'm squeezing this in here. Sorry, guys. What's next?
Water.
H2O and carbon dioxide. Good. So some of you guys who are doing really well in your 9 solutions reactions, where it's just basically 2 solutions you need to put together, there was nothing really funny about those outside of like the random breakdown. Some of you guys were going straight from beginning to NIE. As we go through some of these, you're going to start to notice, oh, well, this is a solid, I can't break it down, or this is a weak acid, I can't break it down. So I think writing the total is important for a lot of us to make sure we're getting in where we need to, okay? So let's do a couple more together, and then we'll let you guys work, okay? Questions where we are? Yeah.
How do you decide which spectator you
The aluminum. So this is what I was trying to make really clear. Aluminum solid is totally different than aluminum 3+ ion. That's like apples and oranges. Since they don't look exactly the same, so aluminum solid looks technically different than aluminum ion in the fact that it's a solid in this case and aqueous ion in this case. They're apples and oranges. We cannot say that they're the same. So throughout that reaction, they were participating. They were doing something. So they're not just spectating. The chlorine 1 minus. Chlorine 1 minus looked exactly the same from left to right, so then we're saying those are spectators because they never changed throughout the course of the reaction. Okay, so keep that in mind. All right, so let's do a couple more. Let's do, oh yes, ma'am.
So on number 3, on the end, H2CO3, how do you know that you're supposed to do that breakdown?
There's only a couple that you'll do that with. Carbonic acid was one of them. I had you guys write them down yesterday from the board. Tell me, does anybody remember what else broke down? Let's just cover that together. I'm just getting some space, hold on. So we had carbonic acid. If the carbonic acid is made, it does that secondary breakdown to water and CO2. What else is it? What else can do something like that? Ammonium, what? Hydroxide. Nitrates are always soluble, so that's not going to be like a secondary breakdown. So ammonium hydroxide breaks down to what? Ammonia and water, okay? If you produce sulfurous acid, or hydrogen sulfate, or sulfide as sometimes it's called, you break down to what? Water and, what's that called? Sulfur dioxide. This is a gas, right? These are liquids and gases. Gas and liquid. Gas and liquid. So basically, that's not an ion, so I'm not trying to make it like an ion. It's not a polyatomic ion. It's just a gas, sulfur dioxide. The other one that's not very, we don't see too frequently, is ammonium carbonate. It breaks down into three things, and this is actually on your NIEs from yesterday. What are three things? Ammonia, H2O, and CO2. So it's basically all the gases that can come from that ammonium carbonate. So that's how you know, and I think everybody can benefit from me leaving that there for you. Okay, so let's keep going. You guys can do, actually, you guys do 4 and 5 first, and then we'll check. Okay, do 4 and 5 first. If you're going past me because you just did it, you're drawing. Okay. You guys have your solubility rules that you write down in your own way. Silver mercury might have a lot of insoluble characteristics.
Silver charge is like always two or one.
Yeah. Go into 5 or 6 if you're ready.
Yeah, it doesn't say chromium specifically, but it says every single time silver consumption is 8%.
Silver chromate is a precipitate. Silver chromate is a precipitate.
You don't break it.
Silver has a 1 charge. Always. Silver's number 1. Don't make me be the cheerleader, okay? That's what you have to do to yourself. Be your own silver cheerleader.
Still always
Alright, pause, come back to me with the silver example. 3, 2, 1, I'm back here, okay? Stop, you're good. Alright, so I am positive, you're good, I don't know why. I am positive you got your silver nitrate with silver 1 charge. You got your sodium chromate with your 2 crisscrossing over. You did a, what kind of reaction? Double replacement, right? I'm just labeling those as we go. Double replacement. It wasn't anything funny with this one. It was just a precipitate. Now, I would give you things that are on your solubility rules, but sometimes we have a lot of ways to work with in chemistry. There's a lot of ions we can put together. Chromate is one of them. So chromate is going to be precipitating with silver. Silver is your suspicious character that you will commonly say precipitates. Once you ionize your soluble salt, and you leave your precipitate, what are the 2 spectator ions? Sodium ion and nitrate ion, right? So then leaving us with 2 silver ions and a chromate ion, which should make sense because when I make this precipitate, what's the ratio I need? 2 silvers for every 1 chromate, right? So that's why the coefficients work out that way too. You can always check yourself at the end. If your numbers are off, then go back up and make sure that you used all the numbers you needed to. Okay, tell me guys how you get started on number 5. H, C2H3O2, and this is the key word that most of you guys are already seeing. Solutions of. If it says solutions of, write it as aqueous, right? So we're going to write this as aqueous. Added to what? Mg SO3. Good. Okay, sulfite. Not sulfide, sulfite. And this is a what? Solid. So you have to write solid because what you guys are going to do is you're going to segment that. You're going to ionize it if you don't write the S because you'll think, oh, it's just a soluble salt. We're going to go. All right, so what kind of reaction? Double replacement. So H what? H what? 2SO3, right? Because our sulfite still has a 2 charge crisscross over. And what? So magnesium acetate with a 2 charge. Okay, or 2 crisscross over. And then I need a 2 right here. Okie dokie. Okay, so we got our balanced equation. We know it says solution of, and this says solid. Identify what is this? What's so special about this? Okay, so technically it's a weak acid, right? Technically it is, but it's one of those weird secondary breakdown reactions, which is this one right here. Okay, so I'm going to just put like a little note up there that's a secondary breakdown. This one is going to be what? Can I ionize this? Yay or nay? Why? Because what? It's not a strong acid, right? So put WA up there for weak acid. That'll remind you, you cannot ionize that. Leave it alone. Yes, it's aqueous, but aqueous doesn't mean it's going to ionize. Aqueous just means it's in solution. Okay? This is a solid. Will I ionize this? No, okay? This is a secondary. We'll get to that in a second. This is a soluble salt, right? It's aqueous because it's acetate, and it's a soluble salt, which means that we will ionize it. So of all these, the only one we're ionizing is which one? The 4th one, okay? So I write this as is, don't touch it, right? 2 acetic acids, because it's weak, I'm not touching it. This one I write as is, because it's a solid, and I can't ionize it. It has to be in solution for it to ionize. This is that secondary breakdown, which is what? H2O and SO2. Okay, so this is a liquid if you want to write the solid or the state of matter. This is likely a what? Gas, because it's a covalent molecule. And then what does this do? Mg 2 plus and 2 acetate ions. Good. All right, so who are my spectator ions? I love when you guys mumble. It makes me happy. Who are my spectator ions? None. Okay, this is it. I can't cancel anything because everything changed to make these products. So everything was involved in some way or form in this reaction. This is your final answer. So what would this look like? Okay, you would take clear, smelly vinegar solution, and you'd pour it on top of this white powder, and it'd mix together, and then what would you see from that? Maybe some bubbles from this sulfur dioxide coming out, which sulfur dioxide is slightly toxic, so we wouldn't like waft that or anything. We really wouldn't see water forming, but it would just be a clear liquid. And then what about this? What would you see? Would you see this? No, it's clear and clear, right? It would just look like, oh, I put two things together, the powder dissolved, and these bubbles happened, and then you wouldn't know anything was actually happening until you did what? Okay, tell me, does this ionize to an appreciable extent? No, that's solid, right? What would conductivity, if I used a conductivity meter and I put it in this side of the reaction as right when they kind of came together, what would the conductivity be? Nil or really, really low, right? And then let's say I stirred it around, I let it react, what would I see over the course of the reaction? With conductivity. Why would it increase? What? Because the products are what? Say again? Ions, so we call those strong electrolytes. All right, we're going to speak the same language sometime. All right, so these are strong electrolytes, so the conductivity would increase over time. That's how questions like this are phrased. It's not like, just write the NIE. It's going to say, okay, during a reaction, this reaction happened. Write the NIE. Over the course of the reaction, what would you observe? And you could technically answer in many ways, but specifically if you mentioned conductivity and you're making a lot of ions, the conductivity would increase. Okay, so note to self, extra descriptive questions sometimes follow these. I like to keep doing these together. You guys want to keep going? Okay. Hi. Okay. Today's 21st? Okay, pass it back to me. Alright, so liquid bromine is shaken with sodium iodide. Ready? What's liquid bromine? BR what? Whoa. Bromine. Oh, and this might just be, you don't remember. Do you remember on the periodic table which ones are diatomics when they were by themselves? It's not a, oh yeah, I want you to tell me. Which ones? I heard N, O, F, Cl, Br, I, and hydrogen. It's the big seven in hydrogen. Those are all diatomic in their states of individuality. So like when they're by themselves, they're not really by themselves. They have a little thing attached to them, which is their diatomic. So it's the big seven in hydrogen. All right, so how do I write bromine? Br2, and it's liquid, so L, okay, is shaken with, so it means it's added to what? NAI. Yielding, before we move on, what kind of reaction is this? Same replacement, but not a metallic one, right? Normally it's like, you know, aluminum and copper, or sodium and potassium, but so those are all our metals. This is a what kind of single replacement? With what? With what? Non-metals, I'm going to say halogens. Okay, the halogens have their own activity series. So with, I'm going to say group 7A, just to very, very specifically say that. The halogens have their own activity series, and look up the article for me. It follows as it's written. Fluorine is the most reactive, so it's the most likely to replace. And then chlorine, and then bromine and iodine. So if the item that's a singleton, like bromine, is by itself, right, and it's above the one it wants to replace, it will occur. So is bromine above iodine? Yes. So bromine will kick out iodine out of that reaction, or out of the bonded situation, to make what? Sodium bromide, and how do I write iodine? I2. And anybody know the state of iodine? It's actually a solid. They're weird. The fluorine and chlorine are both gaseous. Bromine is a liquid, and iodine is a solid. It's something to do with their number of electrons. Okay. So balances, I need 2 and a 2. Okay. And then I identify this as a liquid. Do I touch it for ionization purposes? What's up? We're going to get there. Hold on. So this is a liquid, so do I touch it for ionization? No. This is assuming solution, right? This was aqueous. And then this is an aqueous solution of a soluble salt. How do I know this is soluble? Group 1 metal, right? Group 1 metal, always assume soluble salt. This is making, as this aqueous solution kind of comes together, making another solution. So this is aqueous. This is a soluble salt because of the group 1 metal again. And this is our solid, okay? So, who am I, or tell me what I'm doing for my NIE. Okay, and? 2 Na pluses and 2 I minuses and 2 Na pluses and 2 Br 1 minus and I2. Alright, so who here looks exactly the same from reactants to products? Sodium ion. Sodium ion. Anything else? Nay. Okay, with all of our single replacements, it will always be like this. You will like, oh yeah, bromine and bromine, but they're not exactly the same. Just like on that very first one we did, the aluminum and aluminum ion wasn't exactly the same. So bromine 2 plus 2 I minuses yields 2 Br minuses plus iodine. Okay? And that's our NIE from a single replacement standpoint with halogens. Alright, now you guys go through 10. Go through 10, 7, 8, 9, 10. I'll probably stop you like right when you come up. We are not talking about the unit circle. We are talking about polyatomic ions. You know, I'm doing your homework for you. What you don't finish, you're finishing your homework. So let's go. Alright, so look back up here. I want you guys to check the first ones that you've done by yourself, okay? So some of you, I'm doing them with you so that I'm not wasting time redoing them as you guys are watching. So pay attention as I go over why. I think the first one's obvious. The sulfide is the only precipitate. The only two ions that should be involved to create that precipitate are those that made it, right? So the Ni2+ and then the sulfide. And everything else was soluble because group 1 metals rule. They are always soluble salts. Looking at the magnesium metal, what kind of reaction is this? Synthesis. A lot of times in synthesis, you will not have a solution. You won't. It's like a metal and a non-metal, or a metal and some oxide forming that. Those are usually solids or liquids or gases. They're not solutions per se. So our solid or gas made an ionic compound, and this is just a note to self. Ionic compounds, when they're in their state of original form, they are solids, not solutions. Okay, so you cannot make an ion out of it, non-solution. So that's a solid, so that's why I say don't poof them into ions and go, oh, it's going to be an ion form. It's just a solid. Next one for the solid calcium phosphate. A lot of times, like in like 7, you guys could skip this intermediate step because you can see the one precipitate and make your 2 ions in fat form. But 9's a little more tricky because you had our solid, our strong acid, our weak acid, okay, and then a soluble salt. So the solid stays, the strong acid splits, right? So that's why I was trying to make annotations for you guys to make sure you were clear. Strong acid splits. Weak acid doesn't split because it's not going to ionize to an appreciable amount, stays with us. Soluble salt stays, will split into the 2 ions. So then from there, there's only one spectator, and that's chlorine. So in that case, you have a lot left over. So don't shortcut yourself if you know that you've got some funky business going on, okay? Let's go, keep going through 10 and so forth, okay? I'll keep going as you guys make more progress. Kelly, like that? Sodium chromate with? Who is it paired with? Okay, think back. What is that? Yes. I'm going to do it as splitting. I think after is splitting 1. Because you weren't told any information about, you weren't told any information about 2 completion. No, it will, I see what you're saying. It will react fully. It will react fully, like to make the lithium sulfate. But when you are ionizing this, you do it 1 at a time.
So sulfate is SO4 I think that's probably what it is. I'll just try. I just lost it.
Oh my goodness.
No, you can't. It's SO3. Fierce. So that'd be hard asset too.
I'm trying to do them with you, so I'm not going too fast, but I'm slowing down. I'll put it back up. Wait a minute. You should be trying it first and then checking with me after. Alright, I'm gonna go back up to the 10th one. You guys have had a chance, hopefully, to recognize where the strong acid has a slightly different split than normal, a slightly different ionization pattern, and that's only because it's the one diprotic acid, that's the strong acid in that 6 acid category, and when it's by itself like this over here, we ionize 1 H at a time. Occasionally, they will take this answer, or if you split 2 H's off and then sulfate, so it kind of depends on how the question is phrased, but I'm going to try to make sure you're just aware of this one anomaly. The lithium and the lithium are both soluble salts, doesn't really matter about those. The chromic acid is a weak acid, so we keep it together and intact. So then the only spectator ions will be the lithium and the lithium ion. So 2 lithium ions and 2 lithium ions, leaving us with the split sulfuric acid category, the chromate yielding sulfate and chromic acid. For the last one, we have a general kind of same pattern as normal double replacement precipitates are forming. 1 precipitate forms, everything spectates except for the 2 ions that force the formation of that precipitate. Remember, hydroxides are generally insoluble except for some of those like group 1As and ammonium. Okay, so I'm going to give you guys the rest of the time to work through 22. Okay, you guys got them? You got it? Yeah. Yeah. 12. Does it say, yeah, I forgot how it was phrased.
I was like, what? I'm still on 11. I'm almost there. Yeah, in the air, isn't it? O2. Oh, I feel so too. It could be, but air is not just it has you prefer to be alive, solid, whatever, to make sure that
You'll notice sometimes I'm talking to myself and I print the wrong thing for Guys, don't wait on me. Move on to the next question. You're not helpless. You're not.
I like you. Yes, what? Oh yeah, it is true. Look at that. We're just starting first. Silver string, still water.
If you want to switch to this last section to work, that's fine. I'm going to keep calling out little things at a time though, so just pay attention.
Would sodium take out hydrogen?
Sodium, it's sodium oxide. But I don't think water.
Small pieces of sodium. It probably makes a hydrogen gas. It would take out the hydrogen. Yeah, single replacement. So it's going to take out the hydrogen.
Oh my god, that's all the way down to drawing number 32.
Yes.
It's like
I am. Single replacement. Na2O plus H2. Gas. What is it? I don't know, it's in the sodium salt. But it's probably.
All right, Marcus, go move to lab station. Go. You guys need to focus. I'm gonna need to come in class, or stop talking to each other about nonsense.
Oh, wait. You wouldn't do anything if it's solid and liquid. Yeah.
Solids and liquids can come together to make a solution then. Are you talking about that 14 one, or 13? It'll make a solution of whatever the ionic content of it that is made.
Sodium oxide.
Yeah, that, because solids and liquids can come together and make a solution. That will be aqueous on the product side of it, not on the reactive side. So I'm looking to see if there's one in particular that I would like to do.
like it would break down the oh yeah. It would break down the actually it would
Okay, so solid and liquid combined.
C1, C2, or C3.
Oh,
that would have been
And C4.
That makes sense.
yeah, you don't have the solid. I'll just wait for it.
so hydroxide? Oh, because it isn't.
I just wanted to verify. No. Is this just sodium? I don't know how much.
I thought it was
Is it just? What is it? Just
sodium plus
Yes.
water.
Metal. Yeah, but it's going to be metal oxide. So I was making sure I didn't get you.
So it's not sodium.
No, it is. I mean, that's kind of some replacement Chem. You're right.
Give me 1 second to write this on the board.
It is a sodium oxide, not a sodium hydroxide.
No, it's a sodium oxide and hydrogen.
Oh,
So it acts similarly to steam replacement.
For those of you struggling on this one, here, guys, just sit down for a minute. I can talk to you about this second. For you guys struggling on 13, it acts similarly to a single replacement, okay? Solid sodium metal, right, reacts with distilled water. And I'm writing it as HOH so you can see the cation and the anion kind of collectively together. So then the single-ish, oh no, I think I just told you sodium oxide. It should be the acting like a single replacement. It should be the sodium ion and the hydroxide ion come together and then also produce hydrogen gas as a separate entity. So if you want to write HOH as water, it should give you some clarity to how that reaction occurs. So the sodium and the hydroxide come together, and then the hydrogen gas is made. Now, I was looking back at the notes. I didn't give you the prediction power for that one. That's why I went back to verify we're good there. So the metal oxides in water form something different, but it's just the metal in water. So we're making it act like a single replacement. So this is a gas. So the arrow up means gas. This is a strong base. Okay. So I think you can work your magic from there. Okay. That's a liquid. This is an aqueous, strong base kind of deal. This is a gas. You can work your magic. Thanks. That's it, right? That's right. Yeah.
Yeah, H plus L. H plus. So do you want to throw like all
Above, if it's C3 and up, or sorry, C3 and down to gas, C4 to up.
I'm also pretty happy.
Let's make sure you know what homework is, okay? So I was like,
Hey, that's Valentine's.
so a couple of you guys are doing, I know, taking pictures and so forth. Just a quick announcement. I'm still not done grading inquiry labs. Instead, I've been doing honors kind of stuff. So I'll grade your inquiry labs online. Don't worry about those yet. Don't print them yet. Don't do anything. Your lab notebook's due Friday. The only new lab in there is what?
Which
9 solutions, right? Who's already finalized, meaning completed the 9 solutions, like the identification? Not everybody? Okay, not everybody, so I'll give you guys these answers tomorrow, so you can still write your conclusion, just leave a little space for error analysis, so you can maybe potentially write a couple of sentences about that. You are doing a solution lab tomorrow, and that's the molarity lab. That's a 1 sheet, it's a full sheet. You're simply preparing a solution. That's it. Okay, but read through it so that you understand kind of what we're doing tomorrow so that you can do that quickly. Also tomorrow we're talking about acid-base titrations. So that's why you have a 10-minute video on pH calculations, and if you guys accidentally find that on the dates, you guys watched that last time, then you watched the other ones, the one that was supposed to be for last time. Okay? You guys still got like 8 minutes, you're good. Bye, guys. It's a 5.
Thank you.